walking around on a paper later in life, later in the day. I get it. So let's run through, let's talk through it, and I'm going to be picking on you guys to walk me through some of these problems. What did I do? Okay, so, no, I don't want to open any notebooks. All right. So, it was worksheet 14, correct? And I believe problem 1, 2, 3, and 4, they were probably the easier the ones to get through. So I can bring these up here. So problem number 1, we want A to be -2 and B to be 3. So if A is going to be, what's going on here? If A is going to be -2, I'm plugging -2 in for A, and I'm plugging 3 in for B. Order of operations would say do what first? Are they like bases? Make sure you have your worksheet up, please. Like bases? No? We can't add the exponents. So what is -2 times -2 times -2? -8. So I get -8 times 3 squared, which is 9. So I get -72 for that problem. And then on number 2, I have -2 squared plus 3 squared. Now, guys and girls, why am I putting things in parentheses when there was no parentheses present? Why do you think? Yeah.
It's maybe because the answer you get from -2 to the 3rd power, the -8 compensates for the -2 to the 3rd power.
Right.
3 to the 2nd power and 9 compensates for that.
Okay. So I like where you're going with it. Also, what am I squaring on number 2? I'm squaring A. What is A equal to? -2. So what am I squaring when I put -2 in for A? Am I squaring 2 or -2? -2. So if you put it in parentheses, this is going to tell you that's going to give me +4, that's going to give me 9, which is 13. Okay? Sorry about that. So that's a common misconception in math is, when should I put those parentheses? Anytime you, in my opinion, anytime you substitute in a number for a variable, it's important to put it in parentheses so you realize that whole number is the group number. Now, if it's just like the number 7, then you're not talking about a sign. But if you're talking about like -7 or something that's negative, those are important to realize that will take place, okay? So what Mr. Kruger said as well as what I said are the truths to that. And then number 3, we have -40, and then I have A, which is -2, and that -2 is to the -3. The exponent needs to take place first. What is the exponent? -3. What does that -3 say about the -2? What? It's not going to multiply it. What does the negative exponent mean? It means what?
Go positive. So
Yeah, it wants to be positive.
Put it under 1.
Put it on the bottom. Good. So this whole term right here is going to go under the -40. So I have the -40 over here. I'm going to move -2 to the 3rd power. Why is it now the 3rd power and no longer the -3rd power? Right, you switched the location. If you switch the location from top to bottom or from bottom to top, it changes the sign on the exponent. All right, so what is negative 2 to the third power? So that's negative 2 times negative 2 times negative 2. What's 2 times 2? It's 8. What's negative, negative, negative? Multiply. Negative. So this is going to come out to negative 40 over negative 8. A negative over a negative is positive. 40 over 8 is what? The answer to number 3 is 5. Okay? May I erase? Did we determine what state your quarter was?
Mm-hmm.
What was it?
Maryland.
Maryland. Yeah, buddy. All right, number 4. So starting number 4, it doesn't appear that I have any negative exponents up there right now, so I don't think I'm going to have to move anything around. But I got to make sure I'm plugging a negative 2 in for A. So I have negative 2, 3 to the third over negative 2 squared, 3 squared. Okay, let's take care of all the exponents first. I don't have any exponents that are bad. Let's see. I can go and multiply things out if I wanted to. I could realize that I have negative 2 on top and negative 2 on bottom. Tug of war between the negative 2's. Who wins, the top or the bottom negative 2? The bottom. The bottom, by how many? Okay. Tug of war with the 3's. Who wins, top or bottom 3? Top 3 by how many? 1. 3 to the first is 3. Negative 2 to the first is negative 2. There's my answer. Huh. That says write each expression as a rational expression, and if some of you started these, you probably got to the first couple, and then all of a sudden it started changing languages on you. And that's part of math. It's, you know, your brain is trying to manipulate something to make it work. Okay? Are you hurting your brain by making it think? No, you're exercising it. The glucose production in your brain is getting more, so you're burning more calories the more you think. 4 to the negative 2. What do you think? Angelo, 4 to the negative 2. How are you going to work that? That's it. 1 over 4 squared. Perfectly right. 1 over 4 squared, which is 1 over 16. Okay? So you recognize you had a negative exponent. It had to move. 4, sitting like as it is right now, is actually a numerator. So technically that was 4 to the negative 2 all over 1. Then I had to move the 4 to the negative 2 down because it was a negative exponent. Okay, Celine, what about number 6? X to the negative 3. What do you want to do? 1 over x to the third. Perfect. Okay, the negative exponent said swap places. Okay? Tristan. Number 7. I have x to the 5th and y to the negative 3. So do I have a negative exponent? I'm sorry. On which letter? The y. So what happens to the y? Okay, it turns into a positive. So x to the 5th stays as is. What happens to the y? Where does it go? Y to the 3rd. And does it come down or stay up? Comes down. Good. Okay, so the negative exponent said, hey, swap me where I'm at, so we're now nice again. Okay? Mr. Kruger. Yeah. I have x to the negative 3 and I have y to the negative 2. Happens to be already a fraction. Negative exponents are not happy where they're at. They want to move. I know you weren't here yesterday, but see, excuse me, take a shot. What do you think? And here's a hint. They want to be positive. So how did I make that a positive? What happened to it? Where did it move? Give it denominator. So what do you think is going to happen with that? Where does it want to move? Down, okay? So I have x to the 3rd, move down. What do you think is going to happen with that one? Numerator, good. Or move it up. Like it. Perfect. Look at that. Didn't miss a beat. Love it. All right. Stephen, if I had a letter raised to the 0 power, what's happening? What does that mean? It's 1. So is there anything on number 9 that is just 1? The X's. Okay, do the other letters become 1 as well? No. So this became 1. What happens to y to the negative 6? Where should it go? To the bottom. So I'm going to make a fraction. Comes y to the 6. Now it's a positive exponent. Z squared, is it happy? It's not going to move? Stay on top. Perfect. Okay, so I can have an answer of 1z squared over y to the 6th, or some people don't want to put the 1 there. But again, if you have the 1 there, I think you're totally appropriate. Okay? Tyler. Number 10. Do I have any negative exponents up there?
Yeah.
What has the negative exponent?
The y.
Okay, what's going to happen with that y?
It's going to go to numerator.
What happens to the 3?
It's going to stay.
It's going to stay. So I'm going to get 3y to the 8th power. Okay? And I could have it over 1. It's totally fine to keep it over 1 if you wanted to, but you don't have to.
Oh, that was my question.
Perfect. Love it. All right. George. Number 11. Do I have any negative exponents in number 11?
Yes.
What letter?
Y and z.
Okay. So what are y and z going to do on this problem?
They're going to go down.
Both of them are going to go down?
No.
Which one's going to go down?
Y.
Okay. And what's going to happen with z?
It's going to stay.
It's going to stay there? But if it stays as a negative exponent.
Oh, the z's going to go to the top.
There you go. Perfect. And what's w to the 0 power? So for w to the 0, it's going to become a 1. Doesn't change the whole thing to 1. It just changes the w to 0. So x squared, happy where it's at. You said z was going to move up, right? Y squared is going to move down. Do I need to have the 1 for this? Is it wrong? No, you can have it there if you'd like. If you truly wanted to put it there, you're totally appropriate. Just put it there. But don't, if you start doing that, don't start confusing that for an L. Going, oh, I think it's an L. Where did that L come from? Okay. All right, Preston. Number 12. Do I have any negative exponents up there? On number 12? No negative exponents?
Well, wait, negative, my bad.
Yeah.
Yeah, we have negative.
Which ones?
We have 4x and then negative 3 on to up.
So is the 4 a negative exponent?
No.
Okay.
Negative 3 is.
This is? Okay. What else?
Then we also have the negative 1.
On the z. Okay. Now, what should I do with the 6 and the 4? That's a fraction. 6 over 4. What do you think would happen? If I just had a fraction of 6 over 4, what do you feel you should do with that?
Make it into a mixed number?
You don't have to make it into a mixed number, no. But is there a number that both...
Simplify.
Do what's that?
Simplify.
Simplify. What does it simplify to?
That would be 3 over 2.
Perfect. So that's 3 over 2. Okay, so I know I'm going to have a 3 over 2 so far on this problem. And you told me I have x to the negative 3, so what's going to happen to it? Where does it go?
I would go up.
It goes up. Is it a positive exponent now?
Yes.
Perfect. What about y to the 6th?
That would stay the same since it's positive.
Perfect. I like it. What about z to the negative 1?
That would go up.
Perfect. So we reduced the whole numbers, and then we flip-flopped our exponents that had to move. This seems a little easier than it was last night when you got home and were looking at it. Doesn't it? Refresh you a little bit?
Wait,
Yeah.
that's where you get the 3x3 from?
Wait, where are
Where
we
it
at?
says 3x3 and then 2, 1. Oh, z, my bad.
That's a z, yeah.
Yeah, how did you get the 3x3?
Okay. Well, we knew that we had 6 over 4.
Yes.
and we reduce that to 3 over 2, so the 3 over 2 started it. The x to the negative 3 is down here, so it wants to move up. The y to the 6th is already positive, so it's going to stay down. The z to the negative 1 wanted to move up.
All right.
So the negative exponent wants to switch where it goes, or where it lives.
That was 4x. Yeah.
Wait, what?
That was 4x.
It was originally, but remember we talked in the beginning, we had 6 over 4, and we reduced it to 3 over 2, right? So there's kind of a couple parts here. You have to reduce the fraction first, and then take care of the negative exponents. Once you're done with negative exponents, do the tug of war, or tug of war, depending upon which part of the country you're from. Can I erase these? We good? All right, so let's move it down a little bit. Okay, number 13. Garvey, can I do tug of war? Do I have negatives on number 13? No. So I have 2 raised to the 7th power, 2 raised to the 5th power. Oh, you subtract the exponents. So you went 7 minus 5, you got 2, 2 squared. I like that. So you're saying you just subtract the exponents, so you made that 2 squared. What if I did tug of war? Who would win? 2 to the 7th. Okay, 2 to the 7th would win. Okay. So top wins by how many? Top wins by 2. I like it. Okay. Number 14. Casey, number 14. Do I have any negative exponents first off? Yeah. Yes. So what's going to happen to our negative exponents?
We're going to have to switch.
Okay. I'm going to switch. So y to the, God bless you, y to the negative 2 is now down on the bottom. Y to the negative 5th is up on top now. Is that right? Yeah. Okay. So because they were negative exponents, they swap spots. Okay. Tug of war. Who wins? Top or bottom? Top. By how many? Y to the 3rd. Sweet. Love it. Karen. Number 15. Tug of war with the x's. I have no negative exponents, so we don't have to move anything. Tug of war with the x's. Who wins? Top or bottom? Top. By how many? 3. Tug of war with the y's. Who wins? Top or bottom? By how many? Yeah, buddy. Sweet. Okay. Ray. Number 16. Can I reduce the fraction first? Meaning the 3 and the 6. Okay. What is 3 over 6 reduced to? Half. Good. So we could reduce it to half. No negative exponents, so we don't have to worry about that. Tug of war, who's going to win? Top or bottom? Top. By how many? 2. So x squared, right? Do I have to have 1x squared? Or can I just have x squared? Yeah, it's your choice. Do you want x squared or not? I don't care. If you have the 1 there, great. If you don't want to have the 1 there, and realize that this means the exact same thing. May I erase those? Okay. Ready, set, here we go. Megan. Ready? Okay, problem number 17. Is the 12 or the 8 raised to a negative exponent at all? No. So could I reduce them? Okay, what would 12 over 8 reduce to? Yeah, 3 over 2. Cool. Okay. X to the 4th. The x's are not negative exponents at all. I think I can tug of war them. Who wins, top or bottom? Yeah, it's a tie. If a tie happens, they're canceled. They're gone. I like it. I have y to the 7th, and then I have y to the negative 5th. So what should I do with that y to the negative 5th? Move it to the top. Does y to the 7th move down, though? No, why not? It's not a negative exponent. So this is going to move up. So if that moves up, I have y to the 7th, y to the 5th up on top. Like bases being multiplied, what do I do with the exponents, Megan? Add them, so what do I get? Y to the 12th, good. All right, let's see. Took care of the x's, they're gone. The y's are taken care of. Oh, z to the 0 power is what? 1. I guess I could do tug of war with the z's. Who would win? The bottom by how many? 3. Tug of war. 3 people on one side, nothing on the other. Who wins? Hopefully the 3. If not, there's some problems. Good job. Okay, are we doing all right? Yeah.
So why is it 12? So why the 12? Why is it?
Okay, so y to the negative 5 wants to move up because it's a negative exponent. So that gives me y to the 7th already on top and y to the 5th also on top now. Yeah.
Then how do you have the y to the 3rd?
It was supposed to be a z.
Oh, okay.
I'm sorry. I don't know my alphabet. I didn't watch Sesame Street enough as a kid.
I'm so scared.
I don't know. Especially Elmo. What'd you say? Hi, George. Where's Dorothy the fish? All right. Bo, I'm coming to you on number 18. You ready? Ready? Here we go. All right. So I have 3 and 2 on top, and I have 4 and 3 on bottom. Are any of those 4 numbers I just said, 3, 2, 4, 3, any of them have a negative exponent that's raising it? Which one has a negative exponent of the 3, the 2, the 4, and the 3? But I'm just saying the number, though. I'm not saying the letter. So does the number specifically have a negative exponent? No. Okay, so I can reduce. Now, I could go 3 times 2 to get 6, and I could go 4 times 3 to get 12, or I could reduce, going, oh, 3 and 3 cancel. I can reduce this to that. So what's my fraction I'm going to have for this problem right now? I'm not worried about any of the x's. What's the numeric fraction? 1/2. Is that okay? All right, Bo. Does x have any negative exponents? Are they both on top or both on bottom or split between the two? Both on top. So I'm going to add the exponents. So what exponent for x do I get? Yeah, buddy. X to the 6. All right. Y. Both of them happen to be on bottom. Does either of the y's have a negative exponent? Which one? Which y? Yeah, so the y to the 5th?
Yeah.
So the y to the 5th actually has to move up on top now, meaning I have that. So if I do a tug of war with the y's, who would win in your opinion? Top or bottom? By how many? 2. I guess I could eliminate that 1 if I didn't want it. It's okay to keep. Good job. All right. Oh boy. Figure this one out. I have parentheses. Hang on, we can figure this out, I think. I have 2x in parentheses, and that happens to be raised to the 3rd power. So what math should take place with that right now? How many of those do I have? Am I multiplying all together? 3 of them. So I have 2x and 2x and 2x. So 2 times 2 is times 2, 8. Okay, so that's 8. And what is x times x times x? X to the 3rd. Good. So I'm going to replace the 2x quantity to the 3rd, and now I'm just going to say that's the same thing as 8x to the 3rd. Is that okay to say? Okay. So that's still on top. Gage, you're going to walk me through this one now. I think we can do this. Let's reduce the numeric portion of the fraction. So I have 8 on top and 4 on bottom. What does that reduce to? Yeah, 2 over 1. Good. Okay, so the math that took place here was this 4 goes in itself once, this 4 goes in there twice. Okay, do I technically need the 1 on bottom? Probably not, but I can see where things are going now. All right. Oh, this is going to be a trick question. Okay. How many x's do I have up on top? Carefully look. I have an x to the 3rd, I know. Do I have another x on top? So how many do I have on top then? X to the 4. Does that make sense? So because I have this x here, and then this x here, that technically means I have x to the 4th on top. Okay, tug of war between the top and the bottom. X to the 4 on top, x to the 7 on bottom. Who wins? Top or bottom? Bottom by how many? 3. All right, almost done, Gage. Who wins on the y's, top or bottom? By how many? 2 by 2, good. Because on the bottom that was a 1, right? So I get y to the 2nd. Sweet. So again, do I need to have that 1 there? Nah. Is it okay?
Yes.
I like it. What I have found is if you keep that there, rather than writing another step, if you have it there, usually you'll have the answer right there. It's when you start rewriting your answer not to have it, then you start forgetting other stuff. So if that 1 does take place, cool. Keep it. All right. Kenzie, you ready?
Yes.
All right. Is the negative 30 a negative exponent, or is it a negative number? It is a negative number, so it's not going to switch locations. Does that make sense?
Yes.
All right.
So would it be -1/2?
You're real close, though, because the 30's on top, though.
Oh, 2 over 1.
2 over 1, and it's negative. Okay, so negative 2, and we'll put it over 1. That's okay. Because negative 2 and negative 2 over 1 are the exact same thing, right? Let's see. Does the x's have any negative exponents at all?
The top one.
The top one. So where should it go?
The bottom.
So how many are on bottom now?
There's 5.
Good. X to the 5th on bottom. Did you see what just happened there, everybody?
Would it be negative? Wait, because you added them.
I added it. It moved down, so you just add the exponents. Okay? What about the y's? Are there any negative exponents?
They're both negative.
Both negative. So what happens to the y's?
They switch.
They switch. So what do I have on top with the y's?
You have y to the 9.
So I have y to the 9th on top, y to the 7 on bottom. Tug of war. Who's winning?
The one on y to the 9.
Y to 9. By how many? 2. Cool. What about the z's? Negative exponents at all on z's?
No.
Tug of war? Who wins?
The bottom.
By how many?
2.
There we go. Okay, so again, look, we still have a 1 here. I think it's totally fine if you have that 1 there. Okay, you don't need it. You could erase it if you wanted to, but again, if I accept that answer there, why work harder to get an alternative answer that you might forget a thing? May I erase these? Okay, so the trick on number 20 is realizing the negative 30 is not a negative number, or not a negative exponent, it's a negative number. Okay, may I erase? Feeling all right? Good. All right. Last three. Last three. Andrew, coming to you. Can you see it okay? Squint if you can't see it. I have, what are my whole numbers that I could multiply together right now? And? Okay, so I have, so hang on. So what numbers am I multiplying? I have negative 5 and I have negative 4. And you said that would be 20. Is it negative or positive? Well, I have negative 5 and negative 4. Negative times negative. Is that positive? Okay. Is there any other numbers I can multiply into that mix? And a way to look at this problem too is this. Because remember, order of operations doesn't, or the order of multiplication doesn't really matter, right? So I have how many numbers up there I can multiply together? 3. So I have negative 5 and negative 4, and we've already established that's positive 20. What's the other number we're going to have? So 3 times 20? 60. Good. All right. Are there any letters that have negative exponents? No. Okay. I do have x to the 5th and x to the 4th. What do you think we should do with them? Yeah, buddy. Add them together. And then what happens to the y to the 6th? Do we just eliminate it because it didn't get paired up with anybody, or does it stay around? Stays around. Sweet. Good deal. Woo. Man. Okay. I think I kind of like that one. I think I like the fact that if I rearrange, put all the numbers together and multiply, I think that becomes a little easier to see. And a completely legal move to doing math. May I erase here? So some of you did this, right? Hey, it worked. Cool. Made a circle and tap the middle. I got lucky this time. Okay. All right. All right. Jalen, you ready for me to pick on you?
Yeah.
All right. So let's go slow through this one. Do I have a power to a power on any of my letters?
Yes.
Okay, and power to power means we do what with the exponents?
Which part?
Okay, so when exponents are on top of each other, they multiply. So what does this become?
C to the 10.
C to the 10, good. And what does this become?
C to the 12.
C to the 12. And then I have this 3. I'm going to bring this 3 over here. Is that okay?
Yeah.
Okay. What happens to that?
It goes down with there.
Moves down. I like it. Okay. So let's pause there. Does everyone see where we just made those connections? So power to power, we multiply. So exponent on top of exponent, we multiply. Okay? All right. Your thought. How many C's do I have on top?
2. Or 4.
How many C's do I have right there?
Oh.
2? With the raised to an exponent. So the first one is C, 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 C. 22. There you go. 22. Were you saying 2 or 22?
You're saying 2 because there's.
Oh, oh, okay. I wanted to make sure you weren't saying 22 and I wasn't ignoring you. I'm sorry. So everyone agree there's 22 C's on top?
Yeah.
And the reason there is because C to the 10th is C, 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 and C to the 12th is C, 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 C. Okay, C. I didn't know you're speaking Spanish. Orale. All right. So if I have 22 C's on top and 25 C's on bottom, who wins, top or bottom? By how many? 3 of them? Sweet. So this 3 is coming down. On bottom, that wins. Done. Woo! Damn. All right, I'm erasing this one because, let's see, make a big circle, tap middle. Woohoo! Oh, good, it's like a new toy. It's Christmas right now, man. Okay. Who can I pick on? Who have I not picked on? Casey? You just pointed to Steve? All right, Steve. He threw you on it. Oh, we should be quiet. Yeah.
I can scream again.
Nah. It might be prayer. You never know. I don't want to sacrifice anyone's religious practices if they truly are praying.
We just have like one of those tiny little gong click things.
I've never seen that before. It's just like stands up when he's still asleep. We should do it. I've never seen it.
All right, Steve, you ready? All right. Can you see it okay? Okay. I wasn't sure if you could or couldn't. I mean, I can barely see it, and I'm right here. Can you see it now?
Yeah.
See your thing.
Very
Steve, can you see that okay? All right. So I think we can walk through this problem okay. Let's do this. The 6, the 2, both on top, the 2 on bottom, and the 4. So 6 times 2 is 12, and 2 times 4 is 8. Does 12 over 8 reduce? What goes into both? What? 4. So 4 goes into 12 3 times? And into 8 twice? So 3 over 2? Okay, so I'm just going to write 3 over 2. I know I'm going to have that so far. Is that okay? We took care of that. All right. Get back in there. Okay. Oh, boy. I think we can do this, though. What happens to this x? Okay. What happens to that x? Stays there. Okay. So this one's going to move down. What happens to this x? Moves up. What happens to that x? Okay. So you told me that this x squared moves down. So how many x's do I have on bottom now if that moved down? 4, right? Okay. And this one you said moved up. So how many x's are on top? So I had 8 on top, 4 on bottom. Tug of war, who wins? By how many? 8 on top, 4 on bottom, right? So it wins by 4 on top. Is that right? Okay. Okay. Oh, man. Oh, I'm getting dizzy. Okay, I have a y to the 3rd on top. Is that one happy? Y to the negative 2 on bottom. What's going to happen to it? It moves up. Okay. And then the y to the negative 9 moves down. Does the y to the 6 stay there, or does it move up? Stays. Okay. So I think okay, so if this one moved up, what does this become then? Y to the 5th, okay? And if this one moved down, what did we got on bottom? 15. So 5 versus 15. Top has 5, bottom has 15 in the Y's. Tug of war is taking place. Bottom wins by how many? 10? Yeah. All right. Pat your neighbor on the back or yourself on the back. Woo! All right, ready? All right, you ready? I think I can get through this lecture. Ready? All right, here we go. Let's get rid of that. Okay. All right. Ready? It's going to be quick. I think we can do it. Okay. If I were to take 1014.9 and I were to multiply by 10, what do I get?
10,000.
Okay. What about if I were to take 1014.9 and multiply by 100?
100,490.
1014. Like that?
Yes.
Okay. What if I divided by 10?
Oh, 10,000.
101.49?
Yes.
What if I divided that by 100?
10.49.
It's like, dude, that's the easiest math ever.
I like it. Science, not math.
Okay. Okay. So, if I multiply by 10, the decimal moved right. If I divided by 10, the decimal moved left. If I multiply by 100, the decimal moves right 2 spots. If I divide by 100, the decimal moves left 2 spots. So if I multiply by 1,000, it would move right 3 spots. If I divided by 1,000, it would move left
3 spots.
What if I multiply by 10,000? Moves to the right?
4 spots.
If I divided by
5.
10,000. Okay, so it should work. Let's see. So what happens to the decimal place? It moves to the right when we multiply by a factor of 10. It moves to the left if we divide by a factor of 10. So, God bless you. So 10, 100,000, 10,000, 100,000, million, so on and so forth. Okay. In scientific notation, there can be only one digit. Whoa! What happened here? There can be only one digit. What, did I cuss?
I think someone turned up on that.
One question.
All right. All right. If I wanted to take 9.24 times 10 to the 5th, that's scientific notation. Scientific notation takes really large numbers and really small numbers, meaning really large numbers that go on forever and really small numbers that are decimals, and makes them manageable. So 9.24 times 10 to the 5th means our decimal is going to move 5 spots. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay? If I had a negative exponent, that's going to move it this way. So I'm going to move this 1, put a 0, put a few zeros. So 1, 2, 3, 4, 5. So 0.000483. I think I can finish the rest of this tomorrow. This is what I want you to work on for tonight. Okay? Number 15, which is pages 31 and 32, I would like you to start on number 7. Don't worry about 1 through 6. So, worksheet 15, do 7, 8, 9, 10, And then next page, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Does that make sense?
7 to 20.
Make sense?
7.
7 to 20. Worksheet 15, which is on page 31 and 32 of your notebook. You feel a little bit better about negative exponents?
Yes.
So a negative number and a negative exponent are two different things.